myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And my name of subject is Industrial Instrumentation. This is the chapter number 1 and we are talking about the module number 3. So I hope you already learn about module number 1 and module number 2. So let's start with module number 3. First of all, we are going to see the flow of content. So in this video lecture, we are going to see the transducer and principle of transducers. Then after, definition of transducer, how we can define our transducer. Then after, classification of transducers. So there are different classification we are going to study about. Next is electrical transducer. So why electrical transducer is important among the all other transducers. Then after, characteristics of an electrical transducer. So which are the characteristics that we are going to study. Then after, in last, advantage and disadvantage of electrical transducer. So in this video lecture, we are mainly focusing ourselves on electrical transducer. So begin with transducer and principle of transducer. So the task of a process control system is to control physical parameters. So we need to understand the task of process, any kind of task. Suppose we are working with air conditioner, then what is the task of air conditioner? To maintain the temperature of room, right? So the task of a process control system is to control physical parameters like force, pressure, temperature, level, etc. And to maintain their value near the desired value. As we know, we need to set a temperature of 25 degrees Celsius if we are working with our room, or we can say 23 degrees Celsius. Then it need to maintain the value near the desired value. So AC is trying, or our air conditioner is trying to put the desired value at a 23 degrees Celsius, right? This is because the physical parameter may vary due to the disturbance. So if there are people entering in the room or people leaving the room, then the temperature of the room is going to be changed, or any external behavior of the nature like we are opening the window or other things, then the disturbance is going to vary the physical parameters. So next is to maintain this parameter at a required level, certain correction action required to be taken. So if we need to maintain the desired value near to the true value, then we need to take some required certain action. So starting with the block diagram, that is a set point. So we are setting our temperature at a 23 degrees Celsius. Then after we have comparator. Okay, what the role of comparator over here? Comparator is going to find out what is the actual value and what is the set value. So it is going to define some kind of error. So difference between true value and the set value. So it is going to define some error. The error is directly going to the controller. So what controller's role over here? Controller is calculating the error. It is getting input of the error and perform some desired actions regarding to your process. Then after, control element is going to control some element like fan or compressor or anything else. Then after, it is going to process, and again the output is parameter, and we need to take the parameter directly to the feedback. So the feedback is parameter measurement. So in the case of air condition, we are going to measure the temperature, that is the parameter measurement, and again it is going to directly to the comparator, right? And again we are going to find the error. So this closed loop is continuously running during the time. Okay, so this is our system right now. Now it is essential to measure the actual value of parameter P to achieve proper feedback, right? Nowadays most of the controller are electronic, and hence they require an electronic input. Thus the feedback signal is required in electrical form. So right now we are measuring temperature. So we are not giving the temperature as a feedback. We are converting temperature into the electrical signal, right? Then after we are giving it to the comparator. So we need to convert it into the electrical signal. Then the measurement block include two functions, that is the measurement of parameter and produce a suitable analog signal in a electronics form. So it is going to be produce analog signal or the digital signal to perform any kind of action into the controllers, right? And sometimes the parameter measured block produce non-electrical signal. Hence we required to convert that non-electrical signal to the electrical signal. Suppose we are measuring the force at that time, the feedback or the measurement is in pressure or anything else, or we can say mechanical energy. Then we need to convert it from mechanical to the electrical signal, right? Now next is define transducer. Now the definition of transducer, that is, a transducer is a device which converts a physical quantity to be measured into an equivalent electrical signal, that is voltage or current. So right now, what is the meaning of transducer? Transducer is nothing but energy conversion. Energy conversion means transducer is the device which convert physical quantity like temperature, force, pressure, level, flow, etc. to be measured into the equivalent electrical signal, right? That is voltage, either it can be voltage or current. The physical quantity to be measured can be temperature, pressure, displacement, flow, vibration, etc. Right? That is the physical quantity that we need to convert into the electrical signal. The electrical signal obtained from the transducer is used to control the physical quantity automatically or to display the same as shown in figure. Right now, the physical quantity, that is the input, that is going into the transducer, whatever the transducer, either we are measuring temperature, pressure, displacement, flow, vibration, level, etc. Right? Then after, it is going to give us a output, that is an electrical signal, right? So it is directly going into the controller for the further process, as we already know. This is the controller, right? So that output from the transducer is directly is converted into the electrical signal and going into the controller. Then after, it can either be used to display unit, right? So if we need to see the reading, if we need to see the temperature of air condition, then it is going to display that it is 25 degrees Celsius or 23 degrees Celsius or 22 degrees Celsius, right? So it can be used in both the ways, right? The sensing or detective element is called as a sensor. So what is the sensor? So the sensing or detecting any kind of change we need to detect, that is called as a sensor. It is a device producing measurable response to change in physical condition. So whatever the physical condition is changing, it is going to measure that change in any physical conditions, right? The transduction element converts the sensor output to suitable input form. So over here, figure show the diagram of the transducer, that is the parameter, that is example of the pressure, temperature, any kind of physical quantity, okay? That is directly given to the sensing element. So sensing element is going to sense some kind of change in this category or change in this physical signals. Then after, it is going to give a sensor output. So it is going to give any kind of sensing output. Then after, it is going to given into the transducer or transduction element. Then after, from the transduction element, we can get the same of the physical signal as an electrical signal for the further proceeding. Now next is the classification of transducer. This is also very important term with respect to your subject and your examination, right? So please note down all the topics from this video lecture. Now starting with the classification of transducer. A transducer is a device that receives energy from one system to transmit it to the other system in a different form, that we already know, right? The definition of transducer. So it is going to convert a physical quantity into electrical quantity, right? Then after, the transducer are broadly classified as electrical transducer and mechanical transducer. Now what about the mechanical transducer? If we are going to measure the pressure, at that time we can use a mechanical transducer, right? So any kind of energy, that is the physical energy, into the mechanical energy. If we are converting any kind of physical energy into the mechanical energy, then we can call it as a mechanical transducer, right? The mechanical transducer are transducer that respond to change in physical condition of the system and give output in other form. That is, when a spring is subjected to force, then the output of the mechanical displacement of the spring. The mechanical transducer generate an output signal that is mechanical by its nature, as we already discussed, right? Depending on the nature of output generated, they are distinguished from electrical transducer. So depending upon which kind of output we can get from our transducer, it can be classified as a mechanical or electrical. Now talking about the electrical transducer. This is the main importance of this chapter, that is the electrical transducer. Now what is an electrical transducer? An electrical transducer is a device that convert the non-electrical quantity, that is like force, pressure, temperature, level, force, flow, etc. to an electrical quantity. So whatever the quantity, physical quantity, that is force, pressure, temperature, into the electrical quantity, that is called as a electrical transducer. And what is the electrical quantity? That is either voltage or current that is proportional to the input quantity. So this is the definition of electrical transducer. It is not the definition of any transducer. So if we need to define the transducer, what is the transducer? It is going to convert one physical quantity into the other form. And what is electrical transducer? Electrical transducer, it means any kind of physical quantity into the electrical signals. That is called as a electrical transducer. Now let's see the characteristics of an electrical transducer. Now here are some different characteristics of electrical transducer. First one, that is ruggedness. It means it is the ability of transducer to withstand overloads. So suppose we have a transducer and it have the limit of 5 and we are giving the input of 6. Then what's going to be happen? Its ability need to be higher, so it have some overload capacity, good overload capacity. A good transducer must have high degree of ruggedness. It means it need to be withstand a higher amount of overload or capable of handling the overload capacity. Then after, linearity. Now we already know what is the linearity. The relation between the output and input of the transducer should be linear. So whenever we are going to sudden change in our input, the output need to be changed. That is called as a linear. And linearity is a very important characteristic while selecting the transducer. Next one, that is the repeatability. It is defined as it is the ability of transducer to reproduce the output signal exactly when the same input is applied repeatedly under the same environmental condition. Suppose we are going to measure the current. Okay, if we are using the ammeter to measure the current, and if we are giving the input as a 3 ampere, then our output need to be 3 ampere, or our instrument need to be display the 3 ampere. In each and every time we are giving 3 ampere, it should not vary from 3 ampere. So it is called as a repeatability. Repeatedly we are giving the same amount of input and getting same amount of output. Now accuracy, it is defined as the closeness to the actual output produced by the transducer. So whatever the true value that is we are going to give to our transducer, we need to get the actual true value or closeness to that actual true value of the transducer to the ideal or true value of the quantity being measured. For any transducer, the accuracy should be as high as possible. So whatever change we are going to make in our input side, we can see the same change on our output side. Then after, high stability and reliability. There should be a minimum amount of error in measurement, and it should be unaffected by the temperature, vibrations and other environmental conditions. Suppose we are going to measure a pressure or any kind of current or any other physical parameter, either level or flow or anything, it should not be affected by the other parameters, and if it is affected, then we need to protect that measuring gauge or measuring device, that it should not get large amount of error in its measurement. So our transducer or our instrument have high stability and reliability. Next is speed of response. It shows how quick a transducer responds to the change in quantity being measured. Okay, it shows the how quick. So if we are going to make sudden change in our input, at the same time our output need to be changed very quickly or very fastly. The speed of response should be as high as possible. So whenever we are going to change our input, the output need to be changed immediately. That is called as the speed of response. Now sensitivity. The sensitivity of transducer is defined as the output produced per unit change in the input quantity being measured. So suppose we are going to change our current value. if we are going to change our current value from 3 ampere to 3.5 ampere, at that time our output need to detect that 0.5 ampere change in our input signal, right? For example, the sensitivity of thermocouple is expressed in millivolt per degree Celsius. The sensitivity should be as high as possible. Now, small size. A transducer must have small size, proper shape and minimum volume so that it can be replaced at any location of the measurement. So, transducer need to be a small size, or we can say compact in size. Then after, dynamic range. The operating range of the transducer must be wide to allow its user under a wide range of measurement condition. Suppose we are going to measure a current and we have the ammeter of 0 to 5 ampere. Then we can only measure the current level between 0 and 5 ampere. What if we need to measure the current of 7 ampere? At that time our range need to be 0 to 10 ampere, right? So whatever the transducer we are choosing for our proper application, it need to be a dynamic range. Now moving forward, the advantage of electrical transducer. The advantage of electrical transducer are as follow. That is, first one, that is the electrical signal can be easily amplified with the help of static device or different op-amps, right? So electrical signals are easy to amplify. Then after, the effect of friction are minimized because there are no mechanical part in our electrical signal or electrical transducer. The friction loss is minimum. Then after, the power required of electrical transducer is very small, as we already know, because the power required by the electrical transducer is very small, that is in current or voltage form. Then after, the effect of mass inertia are minimized because of the no mechanical motion. Then after, the electrical signal can be easily transmitted and produced for the purpose of measurement. So electrical signal can be easily transmitted over a long range. Okay, we can also transmit our signal over a long range for a measurement or for a control strategy purpose. Then after, the data transmission through mechanical means is eliminated. Suppose we need to transmit any kind of signals by means of mechanical, it means it is like very difficult to transmit mechanical energy in the mechanical form. So hence there is no mechanical wear and tear, and also there is a possibility of mechanical failure, right? And in the last, with the advent of integrated circuit technology, the electricals or electronic system are compact and have less weight and are portable. Now here are the disadvantage of electrical signal. If we have advantage, we have some disadvantage over here. So the main disadvantage of electrical transducer is that they are costly. So the cost of electronic or electrical transducer are very high compared to other. Then after, also the effect of drift and aging of parameter of components should be taken into account while designing the electrical transducer. So after some time, after some duration of time, our aging effect is going to be there in our electrical transducer. Hence, the design of electrical transducer is little bit of complicated, because we are dealing with certain amount of signals and cables and circuitry in our electrical transducer. So complexity is little bit high than the other possibilities. Here are some questions that are going to be asked with respect to your examination. So note this down very quickly. And this is the end of this module number 3. If you have any kind of questions regarding this module, then please feel free to ask. Thank you.